$5 million Adapting Canadian Workplace Research Initiative. OCEPP is one of the partners in that project, which plans to study the role of Canadian workplaces in mitigating climate change. Warren's international research program focuses on the link between policy and technology for renewable energy and fuels, addressing issues that bridge the gap between researchers and decision makers. His work experience includes stints at the University of British Columbia and the University of Toronto before coming to Queen's. As well as the Food and Agricultural Organization of the United Nations, Warren holds a BSc, an MSc, and a PhD, all from the University of Toronto. Gary Thompson is Supervisor, Generation Planning and Transmission Capacity at Toronto Hydroelectric System Limited and is a member of the OCEPP Advisory Board. At Toronto Hydro, Gary facilitates and leads a team of professionals that plans and enables the connection of all electricity generation infrastructure in Toronto. His earlier roles include Business Manager at Siemens Canada and Project Manager at LXR Engineering. As well, he has developed and taught courses in power systems, electric machines, renewable energy, and business at various colleges. Gary has a Bachelor of Technology in Electrical Engineering from Ryerson, an MSc from Harriet Watt in Edinburgh, and an MBA from York University. Please welcome Warren and Gary.
Thank you. It's always pleasing when I stand at a podium and somebody doesn't ask, Gary, are you standing? As you all heard, I work with Toronto Hydro, and one of the, having been in the industry for over 30 years, one of the things that definitely jumps out at us as we go to work every day is we work in a totally different environment. Gone are the days when a utility simply focused on poles and wires. Today we are, focusing ourselves on energy flow, putting generators in places that they were never even planned or conceived, looking at rates, dealing with ratepayers who never before were concerned, but now want to know where that money that they pay into the meter goes. Our society depends on energy for its own existence. Yet still, it is that very same energy that is taken for granted to the point that we've become benign in what it takes to get it to where we really need to use it. That is, except when we are asked to pay for it. The long-term energy plan is a plan. Our province and our country as a whole needs a coordinated energy plan. After the bandstands of gas plants and feed-in tariffs are gone, our energy infrastructure and our energy needs will still require attention. One just has to look beyond our borders to recognize that LTEP is a plan with opportunities that can take us in the right direction. We can certainly learn from other jurisdictions. So what next? Our profession needs to see LTEP for what it is. It's an opportunity. We as engineers need to seize the moment. We need to engage and transform the plan into something that actually makes sense and can work. So ladies and gentlemen, with those few words, I turn you over to your speaker, Warren. Warren.
It's great, and thank you so much for inviting me to be here. It's a real delight to see so many people here, and I'm really looking forward to this discussion. As you heard from the intro, I'm not actually an engineer. I'm a forester who has drifted into policy and geography and a whole bunch of different fields. So there's probably lots of things wrong in my talk, and I'll give you $5 to the person that can pick out the most wrong things. This is why we're here. Ontario is in the midst of a massive renewal and reinvestment in energy infrastructure. If you go back to 1999, the map here shows very few little triangles. I don't know how well they're showing up on your various screens. Very few generation sites, most of which we're generating a lot of power at. Very centralized power generation. And what's happened Just in the last little while, we've seen massive investment in a distributed power generation system that includes wind and solar, as well as a lot more small-scale power in the fossil realm, gas-fired generators particularly. This requires an entirely new approach, and it requires coordination, and Gary's pointed that out very clearly. In order to move forward, we've got to have good planning. And I really do think that we have the outlines of a great long-term energy plan, and there may be a few things that we can improve on, and maybe we'll touch on those as we go through the talk. So this is the plan. It's a big picture plan. It's got a few kind of fundamental pillars, but probably the biggest things that I draw out of it are the fact that you're bringing communities back into the planning process. This was one of the big missteps, I think, over the last 5 or 6 years of energy policy in this province, is that many things became centralized very quickly as we moved with the Green Energy Act. There were a lot of new projects that were approved and have been built out or are being built out, and communities, I think they felt they didn't have a voice. They weren't involved in that planning. When they had concerns, those concerns seemed to be overridden and maybe ignored. That's turning around. I don't think we've turned the corner completely, but we do have some new mechanisms that can bring communities back in. We also have a strategy of conservation first. It's useful to note that in 2003, when the current government, which is up for re-election now, came into power, there was no conservation strategy, or no really concrete conservation strategy for the province, and they did introduce that, and they've moved ahead with that, and there have been big improvements, big gains, as that conservation strategy has been introduced. And it's important because things are changing very quickly. Electricity has become what I call the common currency of energy. There are so many ways that we can use electricity, and those ways are increasing all the time. We have nice cars. I don't know if anybody saw the new Google car that they introduced just yesterday. I wanted to get a picture, but I couldn't find one. There's all sorts of new options for electric vehicles. The ways in which we use electricity in our houses and in our businesses has diversified massively, and a lot of the things that we do with electricity have become much, much more efficient. If you think about these big screen TVs that are all around you, every year they find new ways to improve the energy efficiency. The first models of these screens were horrible energy suckers, really, compared to the old CRTs. Today, what I've seen is that they're much, much more efficient, and we have basically the opportunity to put more screens in, which we've done. So as we get more demand, we're going to have demand for new generation. And one of the things that I hope is that this increased demand will bring renewable energy options onto the table, and certainly Ontario has been a leader in that area. The other thing is that this increasing diversity of technology is going to provide new options for managing and storing power. You only have to think about your phone or your laptop. Eventually your TV and your fridge will all have onboard computers that can manage when to draw power, when to store power, how to best use the power that they have available to them. And those programs, those algorithms are being written and refined, and it's becoming almost kind of standard deployment. It's not as expensive to do that as it once was. So within the energy plan, I have a few quibbles around the plan as it's presented right now. One of my quibbles is that it's very hard to actually do some comparisons between the different time periods that the plan puts forward. So I tried to put some of that down for you. This is a description of the energy production estimates in terawatt hours between 2013, so real numbers, or as close to real as they had, and 2025. And so you can see that in the bar on the far right, total production is going to be something like 160 to 180 terawatt hours. That's what the production will be by 2025, rising from about 160 in 2013. However, the red bars that are right beside that are the conservation estimates. And so you can actually take those conservation estimates off And that means that by 2025, with conservation, our actual energy production is basically going to be what it is today. Yeah, there's a little bit of a rise, but the energy production is going to stay the same. What's very interesting is the mix. So if you look at the other bars, you can see that not too many of them line up. Nuclear goes way down. Nuclear goes down because of changes in the reactors that we have. We do have some aging reactors. We'll talk about that in a minute. Coal disappears. Coal was hardly there at all in 2013, and it's now gone, as you know. Gas will rise, but it won't rise very much. You know, we're building gas capacity. We're building gas capacity to cover peak demand and to cover interruptions in supply that are associated with the other renewables that are in the mix. We have hydro. We heard a lot about hydro from Stefan earlier. And we know that it's dispatchable, and we will see more of that coming online. We'll get a lot more wind, and we'll get some more biomass, and we'll get some more solar. And that put all together will give us that demand, or energy production, I'm sorry, of about 160 terawatt hours. Changes in production. There's no plan to build nuclear reactors. That's come on and off the table a couple times over the last 6 years, but right now it's off the table. I believe that the agencies are still keeping that in mind, and that there's a planning process so that when we do need a reactor, they can activate that, but that's off the table at this moment. Refurbishing Bruce and Darlington, that will start going ahead as of 2016, and there is a reactor refurbishment schedule in the plan. And Pickering will be in service to about 2020, probably at the latest. The plan says that if demand is covered by other sources, that Pickering could actually come offline even earlier than that. It's not 2020 yet, so you know, I'll believe it when I see it. But this is the plan: is to take Pickering out of the mix, and that's going to be a good thing, I think. Not because I'm anti-nuclear, but because I'm anti-non-dispatchable. And we'll talk more about that as we go through. Changes in demand. So on the other side of the equation, what's going to change? I didn't write down population growth and increased consumer demand, but industrial demand, we're going to see the most growth associated with mining. So mining is probably going to double between 2004 and 2032, from 5 to about 10 terawatt hours. A little bit of growth in the chemical sector, so we see some growth or anticipate growth there. But big declines in pulp and paper, in the primary metals area, and in transport equipment manufacture. We're seeing declines across the board there. And that matches what I know about these sectors, particularly pulp and paper. The pulp and paper sector, you know, has shrunk by about 2/3 across the province. The mills that are left are no longer taking nearly as much power, and the ones that are left are generating more and more of their own power. And so we're starting to see this trend towards self-generation, which means that the number of facilities drawing off that centralized grid is starting to go down. I think that trend is going to continue. We'll talk about that. Capacity versus production. So the dark bars on here are capacity, and the light bars are production as of 2013. Again, I think this is really interesting, useful information. It's a little bit misleading to look at this unless you have some expert knowledge, but I figure everybody here has expert knowledge, so we can look at it without getting too off base. Right now, nuclear, we have capacity that sits up at about 120, what is it? I think it's terawatts? Megawatts? I don't remember which one it is, but we can look that up. Only about 76% of nuclear power is being used, or nuclear capacity is being used in the province. There are reactors that are idled that really don't contribute to that. It's not to say it's only 76% efficient. It's just we're not using all the capacity that's out there. In 2013, we used about 15% of the coal capacity that we had. Of course, today it would be 0. We only used about 20% of the gas, 46% of the hydro. I was a little bit surprised by that, but these are the numbers that are presented in the plan. 23% of wind, that seems about right to me. 59% of the biomass, 20% of the solar. Overall, our whole capacity versus production sits at about 46%. 46% utilization of the capacity that's out there. A lot of that has to do with the nature of demand. You know, the fact that we have big peaks during the day and big lulls in the evening and through the night. And so if you think that we're only using power, you know, typically about half the time, we should be hitting about half the capacity. It does beg the question, you know, could we do better? Could we be storing some of that power, flattening out those peaks, and basically getting by with a lot less generation than we have? This is the way it'll look in 2025. I wrote the capacity factor in above on each of these bars again, but I put them in green if they went up, so if we're using more of the capacity, and almost everything we're anticipating that we're going to use more. And so it's really about using the capacity that we have efficiently. I think that that's a big part of the plan that we have. So nuclear, because Pickering will be idled or taken offline, the remaining reactors will be using about 85% of that capacity. Gas will be at about 21% of the capacity. And remember that we're building gas plants to do the peaks and to handle any intermittency that's associated with some of our renewables. 56% of our hydro, is that good? I don't know if that's good, actually. Maybe we could be doing better. Maybe it's because we're using them as reservoirs, and so only certain times we're using the generation. 30% of the wind, I think that's good. You know, if we can hit 30% of our wind capacity, that's pretty close to the theoretical maximum of what we're going to get off of wind farms. It might be over-optimistic. 61% of biomass, I think that's fine. And then 15% of solar, that one's in red because actually we anticipate that'll go down. I think that's a mistake. We're going to talk more about solar as this talk goes on. It's interesting that overall it's exactly the same, 46% of our capacity would be used through the year. So, you know, again, we sleep and there's night times and that has a big impact on what we do with that. So the takeaway, Ontario's plan relies very heavily on conservation, tools to reduce demand, and then remove your need for new generation or distribution. And we're seeing that, you know, through conservation, we're keeping our demand at about the same level about 10 years out. That's good. It means that we're not looking at massive extra generation. However, we're still building a lot of new stuff to replace the old stuff. Conservation is now sitting at about 5%, and it's anticipated to go up to 16% by the end of the planning period, 2032. Actual generation capacity will only rise slightly, as I said, because we've managed to build conservation in, but the mix is going to be significantly different. It's going to be much more dispatchable. We're going to be able to handle intermittency, and we're going to be able to handle different sources of energy, I think, much more effectively than we've been able to do in the past. More efficient use of capacity in most cases. This leads into the second section of this talk. You can't talk about the long-term energy plan without talking about the Green Energy and Green Economy Act. This is the biggest sort of energy piece of legislation that we've seen in the province in years. Depending on who you are, it's either a marvelous piece of forward-looking policy, or it is a horribly misconstrued sort of instrument that has dragged down Ontario and probably is destroying the economy. Just like the president of the Board of Trade, I'm not going to be partisan on that. It is a sort of a response to the phasing out of coal. We're not just doing it because of that, but that's a big reason, and that did reduce our emissions, and that's a good thing, by about 30 million tons a year. This is the way that the Energy Act looks today in terms of the feed-in tariff. So the feed-in tariff is the most talked about piece of the Green Energy Act. It's certainly not the only piece, but it's the most talked about. And there's all sorts of different numbers that are in there associated with different technologies. And the point came up this morning in the questions, actually, that, you know, we got an act that really kind of related environmental performance or sustainability back to technologies and provided incentives, accordingly, there's probably ways that we could do that more effectively. Right now, the FIT runs between about 40 cents for a very small rooftop solar installation, down to about 7 cents for a larger scale landfill gas sort of recovery system. We actually didn't get too many of those through the province as time went on. We don't do any projects greater than 500 kilowatts through the feed-in tariff anymore. We've moved to a procurement strategy or a different sort of a system for that. And I think it's largely because we've hit a lot of the goals. We've hit a lot of the numbers that we need for generation. We'll see that in a moment. One thing I do want to point out is that we've done some comparisons between Ontario and Germany. Germany was one of the jurisdictions that we really looked to as an example of, somebody who's doing a great job bringing renewables on board. On the right, you can't really read it, I apologize for that, but it's the German FIT rates from 2011, and Ontario's FIT rates have basically just started to hit the rates that Germany was at in 2011. Germany's been progressing since then, so again, their rates are lower. Germany has a very transparent system for adjusting their rates and to doing work, and Ontario hasn't really, and that's been a problem in terms of attracting industry and building things up in the province. So, as I say, Ontario's FIT program, it's been characterized by a few things. One thing is the lack of good tools within the Act to direct investment and infrastructure spatially. Essentially, the spatial tool was if there was a place to connect your project to the grid, it was a good project. As a geographer, I'd have to say that maybe there was a better way to do that. We might have been able to look around the province and identify some likely zones where maybe communities would be more willing to participate, where maybe the resource was more abundant. In Germany, they do have some adders, they have some tools to try to direct investment into certain places. We don't have adders that reward more efficient or effective technologies, and I think that this is a big problem. A solar panel is not just a solar panel. There are lots of different kinds. There's lots of different technologies being developed. The efficiencies are improving. I suppose that the idea was that people will always pick the most efficient technology, and therefore you don't need to build this in. But if the more efficient technology is significantly more expensive, maybe that's what you want to save your high rates for. Maybe you want to push people towards those more efficient technologies. We didn't really do that. I think it was a missed opportunity. Very slow response to changing technologies. We're going to talk about changing prices with solar panels in a few minutes, but we've only just caught up to where Germany was. It's a global market for a lot of these things, and Ontario for a while was really the richest place to go in terms of the feed-in tariff program and the rates that we were offering. And I think that that might have been a mistake. This is what we've done. This information is a little bit out of date, but I'm going with the information that the OPA makes available. So that means I'm a little bit behind. With the latest data that we had about 477 megawatts operating through the FIT program and another 4,000 megawatts under construction, supposed to be coming online. So I'd imagine that those numbers have changed quite a bit. In the planning stages, and this isn't planned by government, this is planned by industry, right? There were over 10,000 megawatts of projects in the pipeline. And that's all straight from the Power Authority and straight from their webpage. It's broken down, as you can see here, but you can see that the total program, if you include everything together, you can argue whether you should or not, over 5,000 megawatts of solar, almost 10,000 megawatts of wind, and just over 200 megawatts of biomass. A little bit of hydro, I didn't put that in there, and that's really what we've done. We also have a microfit program, which is the very small rooftop stuff. It's almost all solar. There is one biomass project in there, so I did include that. 65 megawatts of solar and less than 0.01 megawatts of biomass in that program. If you look at Ontario and you look at the penetration rates of solar power on residential rooftops right now, we have this many households. If I work our way through, just over 2.8 million single-family households, the most likely people to be installing solar panels. At best, only 0.3% of those rooftops are covered with solar panels now. So one of those little houses, 63 megawatts. I think there's a mismatch between what we've got in the long-term energy plan and what we've got through the FITs. If you look at what we're doing with wind, the dark bars are what the LTEP asks for. The light bars are what the FIT is delivering or is working to deliver. We're going to get too much wind and we're going to get too much solar. Maybe it's not too much. We can certainly debate whether the numbers are right, the targets are right in the plan. But right now, the FIT was a pretty popular program, and the number of projects, the number of megawatts that we anticipated coming online are more than the plan needs. And so based on that, you have to imagine that a good chunk of the plans that are in that planning stage will get thrown aside because we don't need them. They're not necessary to meet the goals of the energy plan. And that's including capacity factors, and it's including all of that. On the biomass side, we actually need more, but the truth is that most biomass projects don't come through the FIT. They come through procurement, and they're big plants, that are being run by Northland Power or whomever. I'm getting close to the end, and then there's going to be time for discussion, but a few other ideas to throw out here. This is a typical Ontario day, and this is our demand for power from the IESO. So this is could be a spring day, 15,000 megawatts of peak power, or just maybe 16,000 megawatts. It's 20 degrees outside, so you're not hitting those air conditioner numbers yet. You can see that we do range up and down a fair bit. And this is the way that power is being supplied, roughly speaking. I think I did this last fall. That's why there's a coal number in there. But if you take the coal number out and you imagine maybe there's a little bit more wind, that would be the way that this would be described. And so you can imagine that it's, oh, it didn't show up very well at all. You can imagine that this is sort of how it would break down underneath those peak hours. So what happens as you bring on solar? You can't tell. Well, you can sort of tell. There's a little wedge, a little pie shape that's taken out of that. And that pie shape is becoming more and more significant as more solar projects come online. So remember, that we have 5,000 megawatts that are online or in the pipe from the feed-in tariff, 63 from the microfit. That's a lot of power. At the current time, if it happened today, that would basically take all of our generation capacity offline in the middle of the day except for the nuclear reactors. So that's okay because we can turn almost everything else off except for the nuclear reactors. But that's it. That's all the wiggle room that we have, and that's just with what's coming right now. That's why I think that a long-term plan that actually pulls back a bit on the nuclear front and gives us more wiggle room so that we can do more things during those peak hours is interesting. I'm very cognizant, of course, that as you move past those shoulders, you're right back to the old energy mix. You're not going to get that solar in there, and you've got to have something else to back it up. If you increase the solar uptake, if we look at the German example, and I'm not going to walk through all of that, but right now Germany is sitting at about 3% of their rooftops having PV, and that's what it would look like in Ontario. It'd be about 809 megawatts just from solar power, residential solar power. And that's going to be important as we move towards grid parity. And this whole idea of grid parity, the point at which the cost of electricity from an installed solar operation starts to be lower than the cost of grid-delivered power. Now, of course, that's highly dependent on the average price of electricity. It's highly dependent on factors like your interest rates or your tax rates. It depends on how much solar radiation you get during the year. And so the prediction was that most countries in Europe are going to hit grid parity around 2016. A little bit longer, as you get further north. In South America and in parts of the USA, they're also going to be hitting grid parity around 2016. In Canada, we don't think we're going to hit that moment in 2016, but it's going to be close. And I'm going to show you exactly how close in a minute. Part of the reason that grid parity is moving so quickly is that the cost of solar panels is dropping precipitously. So the experience curves tells us that every time we double solar panel production, you get a 22% cost reduction. Between 2009 and 2012, global production of PV panels was tripled. And so we got more than a 22% cost reduction. We got more like a 50% cost reduction. And in fact, it was greater than that. I think we beat the experience curve. We think that it's going to either double or quadruple by 2017. So we're going to see more big drops in the price of solar panels very quickly. And luckily, within the long-term energy plan, we have some pretty good certainty on where our electricity prices will be. These are the curves that they put in. So the blue curve is from the 2010 long-term energy plan. I'm reporting it in an average dollars per kilowatt, or well, it's really cents per kilowatt. But it's after taxes, after adjustments. It's not the base price, it's the all-in price. And so essentially the old plan, the 2010 plan, said that we would go from something around 18 cents in 2013 up to something just under 30 cents a kilowatt hour by 2030. The new plan has lower numbers, the red line, and so it's saying from about 17 cents hitting roughly 26, 27 cents by 2032. And then, of course, we had the clean energy benefit, the OCEB. And when that was applied, that actually brought those numbers down a bit more. But there's no certainty about the clean energy benefit past 2016. So we don't know what that will do. So I can take those numbers, and I've just changed the graph so that now we've got a taller axis on the side. You can see the same lines down below. And this is what happened in 2010 if you went to buy a solar panel. So the red line up there would be the average monthly price in dollars per kilowatt of the power that you're getting off of a solar panel installed. And this is where it is as of 2014. It's come down by a factor of, more than half. We've seen costs in 2010 when the first participants in the feed-in tariff were getting their 80 cents a kilowatt hour and they were doing their installs. It was costing about $10,000 per kilowatt installed or per kind of unit installed. Now we're talking about $3,500, $4,000 per kilowatt in that sort of a range. And so I've just worked it out with some average interest rates, and I've said that it's a flat amortization, and that's roughly what the cost is. By 2015 or 16, we should be down into this sort of range if we keep following these curves. It's not going to go down as quickly because, we've already made a lot of the gains, but it's going to go down. And what you can see is that under the old one, we would have hit grid parity, sometime around 2030. According to the old pricing structure and according to the old cost of panels. But now we're going to hit grid parity around 2017 based on the price of panels, based on the price of electricity that's already set. And that's just residential pricing. And as you go through the long-term energy plan, you'll see that industrial pricing is actually a little bit lower. So presumably they would hit grid parity a little bit quicker. And what does that mean? Well, on residences, in Germany, they think that they're going to hit 37.4 terawatts of production, terawatt hours of production, which would be 26% coverage. In Ontario, that's over 7,000 megawatts. if we got the same penetration rates that they anticipate getting in Germany and that they're starting to see. That's a lot of houses, a lot of power coming online. But it's not just houses, it's industry. So right now, with the projects that are on the go, we've got about 5,000 megawatts of on-ground and on-roof solar PV associated with industry. I think the ground will go up by about a factor of 1.5. I think that the rooftop will go up by a factor of about 5, and that again is copying the German example. That would take us up to about 8.6 gigawatts of production capacity. And it doesn't show up on this slide because it got stretched out or something weird happened here. But essentially, today, it would wipe out all of our power needs at peak, which is impossible. We couldn't do it. We couldn't accept all that power onto the grid. We wouldn't pay for it. I'm not saying that we would sit down and offer everybody 40 cents or 30 cents or 20 cents a kilowatt hour for this power. But if we did, we couldn't handle it. And if we don't take it and people just use it in their businesses or in their homes, it means that in the middle of the day, our power demand is going to drop. And it's going to drop, towards zero. So if we have a nice sunny day like today, we're going to see big, big changes to the power generation side of things. And this is where, I think that the long-term energy plan is going to have to change. One of the good things about the way that the plan works now is that it's a 3-year plan, so it gets revisited every 3 years. Every year there's an update which provides you with some insight into what's happening, the trends that are happening. So we should see this trend happening before we get there. We shouldn't run into the situation where suddenly the system is overwhelmed. But these are seismic shifts in power generation. It's moving from centralized power generation in the 1990s to distributed power generation through the 2000s and the 2010s, right into personalized power generation in the 2020s, when you see many, many instances of houses or businesses generating the power that they need during part of the day, not all the day, which means you still have to have power to give them the rest of the time. This is a big problem. So the takeaway from that, I think that the long-term energy plan is actually responding to the intermittency and the opportunity that's there. I'm not sure if it's responding fast enough or whether we need to do more, but at least we're starting to build some of those tools in. The reduction in component prices means that solar is certainly becoming more competitive, and we're starting to see the implications of that. And the long-term implications could be staggering. For a province like Ontario, with all the resources that we have, we could see big changes in the landscape. The uptake rates, as expected in Europe, would meet Ontario's peak requirements, not the total energy, but just the peak, and that again is an issue. The National Renewable Energy Lab in the States is looking at this very issue. They're concerned about it because they have actually more solar potential, more irradiation across the country. They think that the real value of PV lies in its potential to offset new generation and capacity and investment, in both transmission and distribution. They should be seen as an opportunity, not as a threat. But you have to see the opportunity to be able to take advantage of it. That's where the engineers come in, because it's the engineers who can figure out how to work with all of this. A couple last thoughts. We have conservation built into the long-term energy plan, and we have a good sense of how to manage for conservation or how to understand the role of conservation. Solar generation is just another form of conservation when you take it away from a feed-in tariff and you move to that personalized side of things. So we've got a mechanism. We actually have something to start with. But the big thing will be energy storage. The long-term energy plan does talk about energy storage, and it talks about research and development of those options. We're going to need a lot of it. And it might not all be big mining pits with pump storage associated. There may be ways that refrigerators could store power during the day. There may be good ways for cars to soak up power at certain times and then provide them back, electric vehicles. There's a whole lot of technologies and opportunities out there. And then just to wind up, Thomas Edison, way back, 100 and something years ago, said, "I put my money on sun and solar energy. What a source of power. I hope we don't have to wait till oil and coal run out until we tackle that." So that's where we are today. With that, I'm going to thank my research team at Queen's and all the partners that fund my work. And I think we have plenty of time for discussion and questions and comments. I'll turn it back over to Gary.
So if you don't mind, we'll sit. So Warren and I are on the same
At
height.
the same height.
Right. Thank you very much, Warren. Some insightful thoughts, and I'm sure some thought-provoking thoughts. We have maybe about 30 minutes for some good discussion, and I would invite comment from the floor, questions at this time.
Hi, Bernie Ennis from PEO. Plans like this are really good theoretically, and I'm coming from a slightly different background. I came out of solar thermal in the 80s. I worked at a lot of solar thermal projects, and I'm concerned about developing a plan that rests on so many individuals who aren't in the business of producing power. When I was in solar thermal, we put up a lot of solar thermal installations that 5 years later weren't working because the people couldn't maintain them, and they just ended up shutting them down and not doing anything with them. So lots and lots of money spent on projects that were funded by the government that went nowhere. This plan, of course, as the rates come down, there's no incentive really to renew the projects afterwards. So what is going to happen if you rely on human beings who get lazy, who can't see the potential in what they're doing, and isn't that a big flaw in the plan?
Thank you, Bernie. Yeah, you're right. When we started to experiment with renewable energy in the earlier years, there really wasn't the infrastructure to support it moving forward. Today, however, the industry is far different. Through innovative and forward-thinking initiatives by organizations like CANSIA, the Canadian Solar Industry Association, there is infrastructure in place, and there is the recognition that once these projects are installed, they have to be maintained. CSA is investing significantly now in training. One just has to look at the discussions in the labor market between the trades as to who is the right person to install and maintain solar installations. And that was actually a ruling that came down last year. So now we have a new classification for certified solar installer, who will become a certified solar maintainer once the stuff gets in. The other thing is I co-chaired a federal committee out of HR, Human Resources Canada, on the human potential required to develop and maintain the renewable energy industry. And certainly the findings from that have been very, very, very encouraging. The colleges, universities, and trade schools that were represented at the table do recognize and are implementing programs to bring that type of skill set to the industry. So there is hope, Bernie, on the calendar. The other thing I wanted to comment on is, and Warren mentioned it, we're moving to a distributed generation environment. 40 years ago, we only thought in terms of Nanticoke, Darlington, even Portland's energy. Today, we're thinking of your neighbor. In the city of Toronto, we have the privilege of managing over 820 distributed generation sites, totaling over 150 megawatts within the city of Toronto. That is where I believe the industry is going. It's distributed generation. As the prices come down, so too do the complexity of generation. In Sweden, IKEA is what we pay contractors in Canada to do to install microfit panels on our house. You can walk into IKEA in Sweden and pick it up, and it's just like assembling their furniture, and it's up and going tomorrow. So that skill set is certainly coming on board. And again, the colleges and universities are putting together programs to make sure that the skill set is out there. So I share your concern. There's a concern that the industry has had, and we're trying to address it to make sure that these things are maintained. Because without the proper skill set, we will see, I don't know if many of you remember back in February, there was the case of the flying solar panels near the Don Valley. Yeah, we don't want to see any of that at all. And that's what you get without the proper skill set.
And I think that point about how quickly the technology is moving and the difference in the technology today versus the technology of yesterday is important. We're moving much more towards plug and play, you know, very, very simple to use, simple to install components that the homeowner can put up and then sort of forget about, which was not the case.
No, we don't want them to forget.
Well, we don't want them to forget.
No.
But you know, it's a little bit like the transition from the old MS-DOS or you know, mainframe type computers moving into the era of Windows and then laptops and now tablets. You know, they've become simpler and simpler to use. People are more comfortable with them. They're more able to keep up. There's another analogy there, which is that, you know, solar panels are moving almost at that same rate. You know, how often does a new iPhone come out? Once a year, maybe twice a year some years if they feel that they've got a good idea. Maybe solar panels are not quite that quick, but they're not slow. How often does a new nuclear reactor come out? You know, they were working on a new generation of CANDU reactors. That seems to have been put on hold as they've kind of transitioned to the SNC Lavalin side of things. I think there's a lot of opportunity. There's one last thing I wanted to say there, and then we'll let the next question go. You started off by talking about solar thermal, and that was what I was going to say to start the whole talk, so I'm glad you reminded me. The long-term energy plan is really the long-term electricity plan. It's not energy per se, you know, and electricity is just one little piece of the puzzle. And solar thermal is a great way of storing power, you know, storing sunlight and having it for when you need it. And so if I was going to say that there's anything really missing from inside of the plan right now, it's how you integrate those different components. There's a bit of lip service to it. They talk about combined heat and power and, you know, how that is brought in. But that's going to be important.
Thank you.
Hi, it's Ann Johnson from the mining department at Queen's. Nice to see you, Warren.
See?
My question / comment both follows up from what Bernie said and asks, well, to begin with, Gary to comment. I live on a farm and I regularly get flyers from companies asking me to rent out my roof, the roof of my barn, whatever, for the installation of solar panels, and I will be paid a rent. And I wonder if organizations such as are sending me these advertisements, if you see a role for organizations like that to sort of manage, like I guess it's an extra layer on top to address the questions of correct installation and long-term maintenance of PV panels. So that was my question to you. But I had a little second question that you can decide to answer or not. I wasn't quite sure of how conservation is measured. Warren, at the beginning you said 5%, we've achieved 5% and we're aiming for, I think, 16% rolled forward. And I just wondered if you could comment on how that gets measured.
Sure.
Thank you.
So with respect to the companies that rent your roof and will put in the solar panels and do all that, I think when solar panel costs were very high, and I'm not saying they're cheap yet, you know, we're not quite at that stage, but when they were very high and when it was a big stretch for any homeowner to think about putting them up, it was a sort of a good idea, you know, because the company could put the capital up, they could, you know, buy panels maybe in bulk and therefore get them at a lower cost, they'd have the installers. When panels were being driven completely by the feed-in tariff, which I think is still the case, it also made sense because you had somebody who could deal with all the paperwork and make the application, and you know, that created the business case for putting them on your roof. What I'm trying to get at is that we're approaching this point rapidly where the business case won't be made by the feed-in tariff. It'll be made by the confluence of the cost of panels and the cost of electricity. And when those two things cross, it's going to look attractive to somebody who has some resources, and I'm not saying everybody in the country will, but some people will, and they will choose to put panels in to offset their electricity costs. And then companies like Samsung, who right now we think of in relation to the wind farms, they'll start making fridges that have good onboard, you know, power management, and they'll start to take in power during the day and run your fridge through the night. And Sony or Samsung or I don't know who else makes TVs, LG, they will build TVs with built-in batteries, just like a laptop, and that's where power will get stored. And this will happen again and again right through consumer electronics. Cars will be bringing on power when it's cheap. I can see this sort of happening, and it sounds very complicated, and it is, but I do think that the rationale will change, and the role of those companies that you're talking about will change. They may still do installations, they may still do maintenance, but they may not be renting your roof anymore. They might be just providing a service. And then with relation to conservation, as I understand it, that's compared to the baseline projections, you know, that were put into place after 2003 to show where electricity demand was going, and then to look at the measures that they might use to bring that electricity demand down, whether that's time of use costs, you know, that bring costs down, or demand down, I'm sorry, whether that is more efficient, you know, appliances or more efficient use of electricity. That's where we're achieving that conservation number, as I understand it. It's a little bit confusing, and actually they should put it in the glossary.
Okay, thanks.
I think.
Okay. Just one comment. And Bernie, you had asked, I mean, what happens after the contract finishes? The sense from the ministry and the OPA now is at the end of the feed-in tariff program will have an end. We cannot continue to, you know, it's like, I'm not going to say giving birth. It's like having a child. You know, there comes a time when they don't wear diapers anymore. And the whole feed-in tariff program will get to that point. And what we will converge to is more of what we call a net metered type of installation. So today, if you're part of the feed-in tariff program, you have a separate meter and you get a check through your local utility from the OPA, separate from your bill. In a few years, 5, maybe 10 years, what will happen is that the energy, the net energy, the energy generated by your distributed generator, and solar is one. I mean, we're beginning to see small combined heat and power gas generators. We're beginning to see hot water storage, especially in Toronto. We're beginning to see all different types of distributed generation. And what will happen is that your generation will be netted against your consumption. Mm-hmm. If you push to the grid, you'll be paid. If you're consuming, you'll be paid for that smaller amount. And that's sort of where the industry is going. One other thing is storage is here. The ISO just closed an RFP for 35 megawatts of storage. That decision, as of last week, is going to be due beginning to the middle of July. The plan is in September, the OPA will come out for 15 megawatts, and that'll total the 50 megawatts outlined in the long-term energy plan. The reality is that storage is a key part of distributed generation. It's a key part of our energy infrastructure. In Toronto right now, we have the privilege of having 4 storage projects happening within the city. 3 that are related to batteries. The other one is compressed air. So very, very interesting technology that's coming at us alongside the developments of wind and combined heat and power and solar.
Hi, my name is Carol Dimitrick. I'm with Isherwood Geostructural Engineers. I found your example about Germany providing leadership interesting, and I just wondered if you would cite an example of where engineers are having more positive influence in other jurisdictions, and perhaps is the situation with engineers influencing policy specific to our region, or is it generally an international issue?
That's a great question. I certainly think it's international. I think that there's examples probably in every jurisdiction of engineers who have been able to influence public policy. I think that Germany, in terms of energy systems, probably gets the gold star, but the United States has also got a lot of leadership from the science and engineering community in terms of developing their energy plans. Their former Secretary of Energy was, a Nobel Prize winning scientist, but if you go through NREL or Oak Ridges, these are nationally funded institutions that are basically there to figure out better ways to create and use and store and power society, store energy, power society. I think that, there's probably bad examples, but I won't try to do the bad examples. I think that what we're starting to see is this kind of opening up of the walls and the silos, and a lot more back and forth between, say, the engineering community and the policy community and the business community as a whole. I think that that has something to do with the nature of our society and the way that we work, something to do with the way that we're teaching. We do a lot more multidisciplinary and interdisciplinary teaching now. And I think it's because the challenges that we face are just so big. It's no longer simple to say, we'll extract this, we'll use it this way, and I'll put this regulation on it. It's got to be an integrated approach. It's not a great answer, but that's what I...
Thank you.
An interesting comment. I'm part of a chartered institute in the UK, and as a matter of policy, every initiative by the UK government is put to the engineering community. So I get an email every time somebody burps in the UK government and thinks energy. I get an email, Gary, what do you think about it? And so does every other chartered engineer in the UK. On the other hand, in Ontario, it doesn't happen. I may get something from the PEO through their initiatives and all that, but there is no official mechanism for engineers in our province to comment. Not that I know of. Maybe our friends from the PEO can highlight if there is, but there's no official mechanism that says, you know what, if it involves technology, if it involves transportation, what are the engineers saying?
I'd agree, yeah.
Thanks.
Okay, thank you very much. My name is Chris Roney. I'm a structural engineer, Roney Engineering. I'm also involved with Professional Engineers Ontario. And one of the questions a couple folks ago talked about or commented that she has a rural facility and people were coming to maybe put solar panels on the roof of her barn or whatever. And then Gary also mentioned the incident of that solar panel installation off the Don Valley Parkway. And so I just, by way of information, as a structural engineer, I get involved from time to time with assessing existing roofs and so on as I see these solar panels installations going up on houses and buildings of various sorts. And your comment about, we're going to get to a plug and play where homeowners can pretty well just buy these things and throw them up on their roof, gives me a few little shudders. Because in my experience, most of the time when I go and assess these things, there's very few existing roofs that actually have the capacity to take the additional effects, not just the weight of them, and there's actually additional effects of solar panel installations on roofs. And to that end, I know that a little while back, maybe a couple of years ago now, the Municipal Affairs and Housing in Ontario looked at putting out a contract to address this in the Ontario Building Code in residential projects, so that houses and small buildings would actually be constructed, their roof systems would be constructed with the reserve capacity built into them. I don't know where that project went. They've abandoned it or put it on hold because they found that's an extremely complicated question, because the effects can be different depending on the geometry and so on. There's so many factors involved. And so it's kind of fallen between the cracks. And so I just raise it that sometimes there are some other policy issues that can come up when you solve one problem, may introduce some others. And I'll get a plug in. Everybody read my Dimensions article this month on the effect of solar panels on roofs. So, thank you.
Thank you.
Thanks. Yeah, hopefully I didn't sound too flip saying, you know, people will throw things up. I actually think that one of the issues is we tend to think of the form factor as being fixed. So we think of solar panels, that, you know, kind of oblong or rectangular panel, as being the fixed form. I've seen some interesting research on integrated roof systems. They look like metal roofs, but they have PV panels or solar thermal built right into them. They kind of look like SIPs, you know, that multi-layered construction. You guys would know that. And they can be installed. They're fairly lightweight. They can be installed like a metal roof. They don't really distinguish between north face, south face. They just put them everywhere, and they're done. And they would plug in, just like I said, right back into the panel. You have your electrician come in for an afternoon, and it's finished. That might be the kind of form factor we're seeing in the future. It's difficult because these things aren't fixed, and they're in transition. And one of the things that we can do with policy is we can encourage the development of the form factor that makes the most sense. And so if we know that people are going to be putting these on roofs, and that we know that there's a lot of roofs that can't really handle the form factor we have today, maybe that's what we try to do with incentives or adders. You know, we can push people towards a choice that makes more sense.
Hello, I'm Tom Stevens from Ontario Power Generation. I was wondering if you could comment on the potential for conversion of energy to handle some of these dilemmas about storage. I was at a seminar given by OCEPP on September the 26th, 2012. A chap from Enbridge there said, we can siphon off all of the fluctuating component of electricity created by the wind, turn it into hydrogen with our electrolyzers of water and all this. And if the hydrogen car takes off, we would be in a position to supply fuel for it. If the hydrogen car does not take it off, we could mix it with our natural gas and use it to heat people's homes. The latter option is not terribly attractive and so on. But it certainly makes an awful lot better sense than dumping steam in our nuclear power plants, bypassing the power turbines and heating up the lake a little bit more with that same electricity. And having the wind basically add 11 cents per kilowatt hour to the cost of that generation and getting nothing at all to show for it. So anyhow, it occurred to me that just about all of these issues can be handled by conversion as well as by storage and all this. Storage inevitably has losses associated with it and all. Yeah. And finally, the other thing is, you talked about Germany. I think we have to be a little careful about what role models we adopt. You talked about how they looked 2 years ago, which is fine. They looked great then. But then along comes Fukushima Daiichi, and you'd think Germans were suddenly terrified of a tsunami of their own or something, which seems improbable in their location geographically. And the French, I understand, made the connection to Germany interruptible because of the impact of the fluctuating wind on their grid and all. So anyhow, that's another side issue, but the most important one is the issue of where the potential is for storage, which is something I didn't hear in your, of conversion, which I didn't hear you talk about.
There is an OPA study out that shows across the province the potential right now for about 225 megawatts of storage. The last IRFP, as I mentioned, came out for 35. There's a lot of technologies out there that are in development. I know of the Enbridge hydrogen proposal. That is a technology in development. What the latest iteration is them using the natural gas system as a storage and transportation network for the hydrogen, mixing the hydrogen with natural gas, then bleeding it off and actually using the hydrogen in a fuel cell type of application. But storage is a unique opportunity to do what a lot of power system operators would love to do, which is shift the peak.
Yes.
The wind blows at night, at 2 o'clock in the morning when most of us are asleep. Storage is ideal because rather than dispatch that, rather than decouple the generators, what you can do is you can store it, and the rates are much cheaper at that time. And then you can take that stored energy and use it during the peak hours in the morning, in the early afternoon. That's the unique thing about storage. Right now in Ontario, we at Toronto Hydro experimenting with compressed air under the lake. And that's a project that will come on stream by midsummer. It's about to start construction very soon. There's a lot of work around batteries, lithium ion, sodium sulfur, sodium nickel chloride technologies. We have put in the first community energy storage facility up in North York at a community center. We're going to be putting another one in conjunction with Ryerson University downtown. Through the benevolence of the Smart Grid program, we are looking at deployment of a lot of other storage pieces of infrastructure. Storage has basically two purposes. One is to store energy when you don't need it and to bleed it back in when you do need it. The other thing is system reliability. So think of it, with all these different sources of energy coming on the system in a compact environment, in an urban, downtown type environment, it does amazing things to the power system. You've gone from having straight pineapple to a fruit salad. And you need to be able to bring some order to that. And what storage is able to do, intelligent storage through intelligent electronics from good organizations like Queen's, U of T, and Ryerson, is to be able to sit there and watch the power system and to provide stored bursts of energy onto the system when it's needed to allow us to live normal lives. And that's the other use of storage. So storage is coming, it's here, and I'm excited about it.
And just one last, I'll throw in a little plug. There is an energy storage project that's underway at Queen's that's related to the fuel cell center, and that would take some of this hydrogen either from water. I think we're actually looking at hydrogen from natural gas. I think the economics are better, but and that would go into fuel cell for stationary generation, not for mobile generation. It's really promising. It looks exciting. It's not quite there yet, which is why a lot of these other options are what we've talked about.
Sheena Sharp, Ontario Association of Architects. I don't know if I read your graph properly, but you were essentially saying that you thought solar was a good thing.
Yeah.
And that we would have too much solar right in the middle of the day. But we all have a price signal that says we should be using power at night. And so as building designers, we're all shifting our heating systems is such that we end up using power at night. But you're essentially saying we have too much in the middle of the day. Why? How is that? How do you see that going forward? Because we're building buildings that are going to last for the next 100 years, right?
Yes.
So
I hope that the buildings do last 100 years. The big issue in Ontario right now is that our nuclear plants are on all the time. And to be honest, water flows all the time. We have some storage capacity in the system. it's not a perfect storage capacity. You know, we can't store up all the hydro through the night that's running through the system in Ontario. It's not quite true in Quebec, where they have more control over the reservoirs and fewer joint international agreements to have to deal with. So in Ontario, we've had a prerogative to start people using their power at night and to kind of flatten out the peaks so that we're using roughly the same amounts of power throughout the day. And that's the ideal, because then you don't have a lot of extra capacity in the system. The free power that solar energy provides us, or free in quotes, it only comes during the day. And if that is the cheapest and most abundant power supply that we have in the future, we're going to have to do some backtracking on this. And I'm not really sure how to handle all that. I'd love to talk to you more about it at some point.
Yeah, an interesting thing that we found, I'm part of a working group with my good partners at Hydro One, and what we found, there is the thought that we peak in the province between 10 a.m. and maybe 2 p.m. But through studies we find that in rural Ontario, we actually decline at 2 p.m. And we wondered why. Well, you see, the farmers get up at 4 o'clock and they go to sleep at 1 o'clock. So that is all part of the social dynamic that's wrapped around distributed generation. And that's why the long-term energy plan talks about community consultation, because we had to go looking for that. If there is a process where we can engage with the stakeholders, I think the days are gone when engineers show up and say, you know what, we're going to put down this great plant, it's good for you, don't worry, trust us, we know what we're doing, just close your windows when it bleaches that black smoke, it'll go away. Those days are gone. I think we really need to engage to manage the sort of peaks and uses, because then if you engage, we can have the architects now building buildings that can accommodate an energy profile. We can have generators, building generators that actually generate when you want to use it, and we can have the homeowner. Now, the other thing that we're missing here is that the long-term energy plan is of both sides. It talks about conservation. Mm-hmm. We've talked a lot about the utilities and the engineers doing a lot on the supply side. But what happens on the conservation side? You know, growing up, we had one 19-inch black and white Philips TV in our house. Today, not because I work for Toronto Hydro, I mean, we're a public utility, we don't get paid much, but I have 3 flat screens in my house. Equal amount of computers. You know, unlike some of my upcoming friends who just bought houses, you know, I have a simple fridge. You can get a Samsung. I saw a Samsung fridge on the weekend that, you know, hot water, cold water, crushed ice cubes with a TV. The demand has quadrupled on the consumer side. And that is what the long-term energy plan is speaking to also, is the conservation. Yeah. In Europe, it's 4 kilowatts per person. We are at 10. And we need to bring that down, because unless we get that balance, we're going to continue spending money, and we're going to continue arguing over all sorts of large infrastructure that costs too much money. But that is the key. It has to be both sides.
Yes. At the back.
Just a quick comment, taking a step back to what Warren had mentioned about, you know, people installing solar panels themselves. And I know much better than to get into a sparring match with a room full of engineers, so that's not what I'm looking to do here. But there's a Toronto-based company called Morgan Solar, and they've just received about $300,000 in funding from the federal government, and they have developed a modular solar system that can be set up in about half an hour, they claim. And I haven't seen it firsthand, but I just wanted to kind of throw that out there as, you know, to alleviate the concerns of, you know, just incorrectly installed solar panels on rooftops and stuff. So maybe Warren knows a little bit about that or can comment about the idea of modular. But I mean, that is kind of I think, what's coming around the corner in terms of future of self-installed solar.
Yeah. And that's exactly sort of the way that I was going. The technologies are becoming much, much easier. You know, Gary mentioned that at IKEA in Sweden, you can buy solar panels. Of course, he didn't mention that if I bought a solar panel from IKEA and tried to put it together, I'd probably get a chair.
That's why you need engineers.
That's why you need
You
engineers.
will always need engineers.
But that is the direction that we're going. It's going to be much simpler to us, not on the inside, you know, for you guys. It'll be simpler for us on the outside. And that's probably a good thing.
Jordan Maxpio. Interesting thought coming to me is whether we've come around full circle in 200 years that we are essentially going back to cottage industry in terms of the kind of generation distribution now that is being projected. And is really that the long-term goal that we want to see, that ultimately people go entirely off-grid? They don't need it's whether it's companies doing their own generation, their own cogeneration, their storage, that really nobody needs the entire massive infrastructure system at all. Is that where we should be going? Is that, what are the kind of risks that can happen with that, whether it's individual residences, whether it's companies, whether it's schools, et cetera, that start to look at this?
To be honest, I don't think we know the answer as to what the optimum size, the optimum kind of way of putting this all together would look like. So the question for researchers and places where I think it would be great to have more and more partnerships with people like you know, the professional engineers, is to start asking those questions and looking at it, because the landscape is changing so quickly. You know, what looked pretty simple in 1999 looks pretty complicated today, and our view through the looking glass, or crystal ball, whatever that would be, makes it look even more complicated. So yeah, it's a great question. I think it's a great point to kind of wrap on before lunch, is to think about that. It's difficult. Okay?
One just has to look at where construction is going. Toronto right now has the privilege of having the most construction sites of any city in the world. Our residential pattern is changing. A lot of these construction sites are condominiums. I mean, we started back with, you know, the tar paper houses outside of, in farmland at Eglinton and Yonge. We moved into the spirals of Don Mills. We went further north into York Region. Now they're coming back into the condos downtown, and that creates a challenge for the energy industry. It creates a challenge for distributed generation. It creates a challenge for everybody. Interesting point you raised there, because we are going back. I sincerely believe we're going to get to the point where each dwelling will almost become self-sufficient with behavior that forces people to live within their energy means. A couple of years ago, some great Western researchers discovered that in rural China, they have a drum with alternating layers of dung, animal dung, and topsoil, and it was enough to light a light bulb every night with just keeping it moist. That's all they needed, one light bulb. You know, we find in North Africa, you know, vases with residues of vinegar and other fruit juices that were batteries. And that's all people, it's a matter of mindset, it's a matter of comfort. And it comes to mind every time we have an outage. We don't want any more ice storms, and we don't want any outages. But it's amazing how adaptable people are to their environment. And I really think we're getting back there where we will have these homogeneous energy cells within our house, and we'll be very comfortable, and it'll just be what we need. And I think with that, we will. Thank you.
Okay, we really do need to stop things at this point. We have to give the staff time to sit up for lunch. With that, I'd like to thank Gary and Warren for promoting it, pushing this discussion, like the audience, and thank them for the questions. I think we've all learned a lot about what is still a very complex issue. So formal thanks to Gary and